The first one, again, I just want to mainly go over that kind of factoring, but you guys have all hopefully had a couple years of solving by factoring, so it shouldn't be anything too awfully new to you. I'm going to go through the long method. I'm not going to do any of the little fancy tricks with this. If you've learned with the little fancy tricks and you like using them, that is fine. Again, I don't grade you off for not using my method or anything like that. You can do it however you want to. I don't care. But I'm going to use the long and mathematical method. Huh? Solving by factoring. All right, so you have to start by multiplying to whatever the first times the last number is. So in this case, that'd be negative 12. So I get that by taking the first number times the last number. And then we always have to add to that middle number. So in this case, that would be a positive 6 and a negative 2. Okay, and then what I really want is I don't want to factor with an odd number of terms. I always have to have an even number of terms to factor with. So the entire point of doing this is to get an even number of terms. So I found those two numbers so that I can split this in a way so that I can do factor by grouping. So I can split that middle term in any way I want to, but if I split it using any other numbers, factor by grouping won't work. So that's why we have to do it using this method over here so that my factor by grouping will work. Now, wherever I group, technically what I have to have is a plus sign in between those. A lot of times, a lot of math teachers get a little fast with that, and they never put anything in between there. They just put their parentheses really quick and move on. You have to have a plus sign, because otherwise that means multiplication, and that's not technically correct.
Wait, so whenever we need the word, you want us to have a plus sign?
I'm not going to get picky with it. I just want to make sure that it gets all explained this first time. And I understand where you're going through the work. You understand what you're doing, and I'm just as guilty as the next person of wherever I'm doing my work quickly, I may not go and put a plus sign in between there.
Would it be bad if you put if you make some mistakes in there too? Like, how do you know?
Nope. Since addition is commutative, if you put them, all that's going to happen is wherever I get my factors down here at the bottom, they'd be switched around, which isn't going to matter at all. All right, so factor by grouping, I take out what they have in common. So they have a 3x in common. So that's going to leave me with an x plus 2. These both have a negative 2 in common. So that leaves me a 3x minus 2 and an x plus 2. So switching it around, all that would do is out here you would have your x and your plus 2, and in here you'd have your 3x minus 2 and your 3x minus 2. Okay, so wherever you solve by factoring, you take each of your factors and you set them equal to 0. So this one's going to equal 2/3. This one's going to equal negative 2. All right, you okay with that? Any questions, concerns, issues? Okay. All right, isolating the square. Am I okay to move on? I don't want to go too fast. I promise you short notes, but I don't want to rush. All right, isolating the square just means that you get the part that's squared by itself. Once the part that's squared by itself, then you can square root it to get rid of the square. So we treat this part like kind of like a single variable. So we solve the rest of the problem totally ignoring what's right there. So I'm going to solve it like normal. I'm going to go through and I'm going to add 5 to both sides. Then I'm going to take and divide both sides by 3. Now that I have the square by itself, now what I can do is I can square root both sides to get rid of that square. I just divide both sides by 3. Now, the only thing you have to be careful of, anytime you introduce a square root into a problem, you have to do the plus or minus. Okay, then whenever I subtract this 2 from both sides, conventionally what we do is we always, anything we do, we put in front of the plus or minus so it doesn't get confused what the plus or minus applies to. So anything the plus or minus applies to goes behind it, anything it doesn't apply to goes in front of it. And that's just for the sake of confusion. Now, if we can't do the addition and subtraction, we would leave it like this. In this case, we can actually do it, so we go ahead and solve it out and get our answers. So if I take negative 2 plus 2, I would get 0. If I take negative 2 minus 2, I would get negative 4.
Thing that my teacher did with it, circled something, and that was like the answer. Is there something else being the squares?
If you ended up with something like this, that would just be your answer. I don't know if that's what you're talking about.
There's like a square where like they like circled certain numbers and they squared it, and then like I don't know.
And there's always tips and tricks.
It might be a different type of problem.
The-
Like in square.
The problem with tricks is tricks never always work. I can show you little tricks with lots of things.
Do we have to like write our answer like that, or can we write it? Like
No, you can write it like that.
But they only work for like this math, they work for like everything.
If it works for everything, great. You
So
can use it.
saying you use the stuff that always works.
No, I use things that always work. But the problem is, most of the time where you have a trick, it doesn't always work. It works for the simple things, it doesn't work for everything.
There are two just math that we can stick with.
To everything.
There you go.
My wife brought home this thing with an addition problem that was like this really cool trick you could use with subtraction, so you never had to borrow. So then I showed her a problem where you couldn't use her trick and you still had to borrow. Like, you know, it's great whenever you have those tricks that really help kids so they don't have to use conventional math. The problem is tricks don't always work. There's always a time whenever a trick doesn't work. And that's why, you know, we have these ways that we always, that are, you know, that's why they were taught the way they were taught. And we always come up with nice little cool tricks that you know people see on the internet and they think, oh wow, that's a magic trick in math. No, it's not. And a lot of times whenever it seems that way, it only works for that one time or that one situation. Okay. Rationals. Okay. In order to do these problems, for a math person, I don't like doing problems with fractions. I love getting rid of my fractions. So I'm going to show you how to get rid of the fractions. You could do this problem with the fractions, but in the end, you're going to have to get rid of the fractions anyway. So I prefer getting rid of my fractions to begin with. So what I suggest doing is starting by finding your lowest common denominator. The way you do that is you always have to start by factoring. Now, these problems are always set up really nicely. So whenever you factor, oh, amazingly, these factors on the right-hand side match the ones on the left-hand side. Okay, so this ends up right here being my lowest common denominator. So what I want to do is I want to take and I want to multiply it's lowest common denominator because every denominator has those. So if I were to make all the denominators the same, I would need, this one needs an x plus 3, right? This one needs an x minus 2. This one doesn't need anything. So that's what I would need if I would needed to make all the denominators the same. So what I'm going to do is I'm going to take all the fractions, I'm going to multiply them by this. Now, just to make a point, what I'm going to do is I'm going to put this over 1. What that's telling you is I'm multiplying both sides by the same thing. I'm writing this out in more detail than what I need to do. On this side, what it does is it distributes out. So what happens is you actually end up multiplying every single fraction by the same thing. And again, I'm writing this out in more detail than I would normally do if I was doing this on my own paper. Just, again, to make sure you guys see, everything I'm doing. Okay, so that's what I have. I took the lowest common denominator, I'm multiplying everything by that. What that does is that gets rid of my fractions. Because over here, my x minus 2's cancel out. So then all I'm left with is x plus 3 times 1. So I simply have x plus 3. Over here, my x plus 3 cancels out with my x plus 3. So all I have is x minus 2 times 3. So that's 3x minus 6. On this side, everything cancels out. So all I'm left with is 4. So now with my actual solving, I don't have to worry about fractions. My fractions are gone. All I have to do is solve. So let's see. 4x minus 3 equals 4. 4x equals 7. So x equals 7/4. I'm done. Yeah. In order to cross multiply, there are problems where you can cross multiply. In order to cross multiply, you can't have this plus sign here. If you had a problem that looked like this, that kind of problem, you could just cross multiply. So if you do end up with problems without the plus sign like this, you can cross multiply and solve. I would still, in that case, I would say simplify first, because both sides here, you would have this. By simplifying, both sides have an x minus or x plus 3 on the bottom. That will keep you from, because if I just cross multiply here, I'm going to end up with things with x cubed in them, right? By simplifying first, I simplify my problem so that I just have a problem like that without any x cubes in it. But yes, you can cross multiply as long as you don't have the plus. Yeah, Taylor.
So when you do the 3, like 3 over x plus 6, if you distribute the 3 to each.
Yeah. So what I did here is whenever I multiplied this went to those two.
So it didn't even go to the x plus 3.
Nope, because that disappeared. So whenever I cross those out, it's gone. So I did the cancellation.
Okay.
Now, there's one more step you have to do with this. Since you have fractions here, you have to double check that this doesn't create zeros in this. So you have to make sure to check your solution. Now this one didn't create a zero in the denominator, so I'm fine with it. But if I would have got x equal 2, then this problem would have been a no solution problem. Sorry, here. All right, any other questions over that?
Yeah. What if, when you did the zero, what did it,
Then just throw that solution away.
so would it be no solution?
Yep. Okay, so do you need to go get a drink, Taylor?
No, okay.
Okay. There you go.